All right, let's jump right in. We are about to look at a technology that literally smashes together some of the most complex engineering disciplines on the entire planet. We're talking robotics, edge AI, and Web3, all combined to create something that sounds like pure science fiction. But believe me, it's happening right now.
I mean, just get that picture in your head for a second. A robot, maybe out in the middle of a forest somewhere, runs into a problem it's never seen. So what does it do? It thinks. It writes a brand new piece of code for itself, and then just kind of chills out on a rock to sunbathe and recharge its batteries. It's such a powerful image, and it's the perfect way to get into what we're talking about today.
And just so we're crystal clear, that scene I just described, that's not from a movie. This right here is the GAPbot. It's the real deal, the physical body of an entire ecosystem that's been built by a company called CoraxCoLAB. And what they're doing is fusing all these incredible technologies into one single unified system.
So, to really get how this all works, we've got to start with the brains of the operation. This is the invisible software layer that's pulling all the strings. Let's dig into what they call the Green Automated Platform, or GAP for short. You can think of GAP as the central nervous system for this whole thing. It's the connective tissue that runs all the way from the cloud down to the actual silicon chip inside the robot. Right now, it's at what's called Technology Readiness Level 7. Now, what that means is it's moving way past the cool demo stage and into full-on commercial deployment. So the way they've built the software is really, really smart. They combined two things, Flask and Fast API, which at first glance might seem a little weird, but it is a brilliant solution. See, Flask gives them that rock-solid, step-by-step processing they need for all the critical business stuff, security, financial data. But then you have Fast API, which is built to handle the absolute fire hose of real-time sensor data coming from the robots without ever missing a beat. So you get the best of both worlds, total stability and insane speed.
And that practical approach, it extends to how it connects with everything. Corax is basically a universal translator. It doesn't care if your factory is running on ancient tech from 1979 like Modbus or the very latest IoT sensors. Corax just sucks it all in, makes sense of it, and applies its AI logic. So here's the kicker. This saves their clients millions of dollars in custom integration costs, and it gives CoraxCoLAB a huge advantage in the market. Now, this decentralized thinking even applies to how the robots work together. It's called swarm intelligence. So instead of having one central server telling all the robots what to do, which is just a massive single point of failure waiting to happen, they use something called the consensus-based bundle algorithm. When a task comes up, the robots literally hold an auction among themselves. Each one calculates how fit it is for that job and then puts in a bid. The network then mathematically proves which robot is the absolute 100% best choice. It's a decentralized system that is, for all intents and purposes, indestructible.
But here's the thing. In a world with heavy regulations like the EU AI Act, a black box AI is a legal nightmare. If a robot makes a decision, like shutting down a valve, you have to know why. And that's where CoraxCoLAB uses what's called explainable AI. This XAI layer is like a forensic accountant that translates the AI's crazy complex math into a simple log that any human can read. It's basically automated legal protection for their customers.
Okay, so we've covered the brain. Now let's peel back the next layer of the onion and look at the physical body that actually gets things done in the real world, the GAPbot itself.
And here it is, a six-legged hexapod. The first question you're probably asking is, why legs? I mean, 99% of mobile robots have wheels, right? Well, yeah, wheels are great if you're on a polished factory floor, but they're totally useless in a muddy field or a forest or a disaster zone. Legs, on the other hand, can step over stuff, they can climb hills, they can handle the beautiful, unstructured chaos of the real world.
And this thing isn't just a body, it's an absolute beast on the inside. It's a supercomputer with legs. It uses a powerful vision model to see the world. And then it hands that information over to a large language model to actually think and reason. And here's the most important part. All of this happens right there, on the robot itself, at the edge. This completely gets rid of the cloud latency that just cripples so many other autonomous systems.
This local processing power unlocks what is basically the holy grail for autonomous systems, self-healing code. The GAPbot can run into a totally new problem, write a software patch for itself, compile it, and then execute it, all without a human ever getting involved. But of course, that raises a pretty massive security question, doesn't it?
How do you stop a robot that can write its own code from going rogue? Well, the solution is a concept called GBNF control. It's like a safety grammar.
Or you can think of it as a straitjacket on the AI's creativity. It provides this really rigid template of commands that are allowed, and it makes it mathematically impossible for the AI to generate any code that falls outside of that safe, pre-approved structure. It's the freedom to heal without the freedom to ever cause harm. So we've got an incredible brain and an incredible body. But what does all this tech actually do for a customer? Let's talk about the staggering real-world value that it creates.
This number right here is just wild, a 2.9 LTV to CAC ratio. I mean, those are the kinds of margins you'd expect from a pure software-as-a-service company, not a business that's deploying heavy, expensive, cyber-physical hardware. It just goes to show you how incredibly efficient this entire ecosystem is from a business perspective.
And hey, the proof is in the pudding. Look at these KPIs from actual real-world deployments. We're talking a 20% reduction in fertilizer use, 15% less machine downtime, and an absolutely staggering 44% in water savings. These are not theories on a whiteboard. This is concrete, tangible return on investment.
And the platform is just so versatile. In agriculture, it's using probes on its legs to perfectly optimize soil. In factories, it's using thermal and acoustic sensors to predict when a machine is going to fail. In our homes, it can provide ethical automation by processing all biometric data locally, so nothing goes to the cloud. And in crisis management, it's saving actual lives by going into dangerous places where humans can't.
Okay, now we get to the final and deepest layer. This isn't just about what the system can do today. It's about the security and the forward-thinking principles that make this whole thing trustworthy and built to last for decades to come.
So here's a threat that literally keeps cybersecurity experts up at night. It's called Harvest Now, Decrypt Later. Basically, bad actors, nation-states, are stealing today's encrypted data. All of it. Your financial records, your industrial secrets, and they're just storing it. They're waiting for the day when quantum computers are powerful enough to crack today's encryption wide open.
So what's CoraxCoLAB doing? They're deploying post-quantum cryptography today. They're already using next-generation algorithms based on math so unbelievably complex that even the supercomputers of the future won't be able to break them. This is just an incredible level of strategic foresight, basically vaccinating their clients' data against a future that's already on its way. And that foresight extends to regulations. For most companies, new rules like the EU's deforestation regulation are a total nightmare of paperwork. The GAP platform just flips that on its head. It turns compliance into a simple, automated background process, using mathematical proofs to generate reports that can be read directly by the regulators' machines. And this whole system is held together by what's called a Web3 trust layer. They're using blockchain to create an unchangeable, time-stamped chain of evidence. They're even using NFTs, not for speculative art, but as a way to securely license and sell AI models, creating a whole new economy for innovation. And by open sourcing some of their key tools, they're helping the entire ecosystem get smarter, faster. So, when you finally pulled all these different threads together, you see what's truly going on here. CoraxCoLAB has built a system where technology and nature, where profitability and sustainability are not fighting each other. They're part of the exact same self-optimizing system. It's honestly the absolute pinnacle of cyber-physical engineering. And that leaves us with this one last, absolutely massive question. You know, we've always thought of our infrastructure as something fragile, something we constantly have to maintain and fix. But what happens when it can feed itself with solar power, heal its own software, and coordinate with its peers? What massive new frontiers are we as humans finally freed up to explore when our infrastructure, for the first time ever, starts to take care of itself?